Hello, today we're going to be looking at symmetric functions, and our focus is going to be on even and odd functions. So what are symmetric functions? A function is said to be symmetric if one side of the function or the positive side of the function appears to look like a reflection of the negative side. Take for instance, I have these two graphs here, centered on both even and odd. Let's critically look at the symmetricity of the even function here. If you look at the positive side of this function, which looks like this, it has a negative side which appears to be like this. So if you look at this negative side and the positive side, it's as if this negative side, which is this side, is a reflection of this. So in that case now, the y-axis is acting as if it's the mirror of reflection that reflects either the positive to the negative or the negative back to the positive. So functions that appears to look like a mirror are called symmetric functions. All right, let's look at this odd function here. If you look at the odd function on this diagram, I think I have this that sank into the origin, and I have this out of the origin. So if you look at above the y-axis, the function appears to look above as a reflection of below. Now look at this. This is above the y, then this is below the y. So in this case now, we say that this function is actually symmetric. But the difference is that this is symmetric about the y-axis, while this is symmetric about the origin. So the spinning of this one to produce this is on the origin. So if you spin this circular on the origin, you're going to produce the symmetric function on the other side. Now, if you spin this one about y, you're going to produce this. Take, for instance, if I have this to be my y line now, and I have this function, if I spin this, I'll produce the entire function or entire graph. All right, so mathematically or algebraically, we say that a function is said to be even if f of minus x is actually equal to f of x. That means that for every negative value of the function produces a positive result. And if you look at this, for every negative x here, the function has a corresponding positive y. And for every positive x, the function has a corresponding positive y. So, and also for every negative x, the function also has a negative y here. And for every positive x here, the function also has a negative y. So if the function was positive y on both sides, the function will as well be negative y on both sides. All right, so now let's take a very quick look at an example of an even function. A very good example is the function f of x equals x squared. Now let us critically look at f of minus x. F of minus x is actually going to be like minus of x all squared. Okay, and this is still something as x squared, which is still something as f of x. So we can see that f of minus x produces f of x. So in this case, functions like this are actually even in asymmetric nature. And the graph of this function of f of x equals x squared looks like this. The graph of this function looks like this. And it is about the origin. Actually sank into the origin and came out of that. Every positive value here, say x, there's going to be a corresponding negative value, which is minus x, that produces the same result about y-axis. All right, so let us come back to this place. A function is said to be odd algebraically if f of minus x produces minus of f of x. Example of an odd function is this function f of x equal to s cubed, sorry. F of x equal to s cubed. All right, so let us critically evaluate my f of minus x. F of minus x in this case gives you minus x all to the power of 3, of which minus x to the power of 3 produces a minus x to the power of 3, which gives you a negative of f of x. So you can see that f of minus x in this case gives you a negative of f of x. So we call functions that behave like this odd, while we call functions that behaves this way, producing f of minus x to be f of x even. All right, I have three functions down here, so we're going to classify them under even or odd or neither even or neither odd. All right, so let's look at the first one. F of x equal to s cubed plus 3. All right, so let's look at f of minus x now. F of minus s gives us minus of s cubed, all right, plus minus of x, of which this gives us minus of x cubed as well. When I multiply this 3 times, I get minus of x cubed minus x. All right, so if I factor negative here, I'm going to have minus in bracket s cubed plus x, which is still the same thing as minus of f of x. So in this case now, we can see that f of minus x produces minus f of x, satisfying that the function is an odd function. All right, let us look at this one, g of x. Now let us look at g of minus x. G of minus x in this case now is going to be 1 minus of x to the power of 4, of which the power here is even, so the negative multiplies itself 4 times and it remains positive. So this is going to be equal to 1 minus x to the power of 4, and this is still something as g of x. So you can see that g of minus x gives you g of x. So this function is even. All right, let's look at the last function there, which I have h of x equals 2x minus x squared. Now let's look at h of minus x. H of minus x gives you 2 multiplying minus x minus of x all to the power of 2. So anywhere I see x, I will replace it by minus of x. So this gives me minus of 2x, right, minus x to the power of 2. So in this case now, you can see that I can't really factor this. Even if I factor the negative, I'm going to have minus of 2x plus x all squared. So in this case now, we can see that this function here, when the negative is factorized, is not a negative of f of x. As you can see, f of x, sorry, h of x initially is 2x minus x squared. But in this case now, I'm having negative of 2x plus x squared. So these signs conventions inside are not the same. So in that case now, this function is neither even nor odd. This is neither even nor odd.